Hello and welcome to 2.1 Lesson 2 on quadratic equations and their graphs. In Algebra 2, you guys probably spent a couple weeks learning how to graph quadratic equations, and hopefully you already know that quadratic equations form parabolas. Their graph is a parabola. And something that you might not have realized is how prevalent parabolas are in our real life. If you go downtown St. Louis, you can see the St. Louis Arch. That is a parabola. You've got the Roman aqueducts that carried water. Flashlight, the lenses on light bulbs and flashlights have a parabolic dish shape. Speaking of dishes, you got the satellite dishes that give us nice high definition television where the focus is, and that's something that a lot of books don't get into, but it directs the rays right to that middle point that sticks out of the middle of that dish. That's how you collect the signals for your televisions. Also bridges. In architecture, parabolas are very prevalent. They're pretty and very structurally sound. Roller coasters, we all love going up and down roller coasters. And let's go bananas. You could actually make a quadratic function out of a banana and putting it on the axis in that. I thought that was kind of interesting. I thought maybe we will go bananas. Maybe we'll have you get a banana and find the quadratic equation that fits that banana. Let's go into the two different forms of quadratic equations and what we can find from them. First off, the standard form, and that's your typical quadratic equation, and you can find the vertex using a formula. Now you have the standard form and the vertex form, two different forms, but they do the same thing, and you can pick different items of information off of them. Just realize that they're the same thing. You will get a parabola if you graph either of these. If you have it in the standard form, I like the plug and chug formula. To find the x-coordinate of the vertex, you'll just take the opposite of b divided by 2a. Once you have that number, you put it back into the quadratic equation for x to find the y-coordinate. So we'll plug that number back in for x, and then that'll give us the y-coordinate of our vertex. The axis of symmetry here is always the x-coordinate of your vertex. So negative b over 2a is the axis of symmetry. Axis of symmetry, as you know, parabolas are symmetrical. You can fold them in half and they'll go right on top of each other. The y-intercept from the standard form, all you have to do is look at the constant. 0, c, that is the y-intercept. For both forms, it has the a. See that a there? That gives us the vertical stretch or shrink and whether the parabola opens up or down. If a is bigger than 1 or less than negative 1, it stretches your parabola long and skinny. If it is between negative 1 and 1, in other words, it's like a fraction. And it will make it flatter. It'll make it wider at the bottom, so it shrinks it vertically. If it's positive, if a is positive, the parabola is going to open up like a smiley face. If it's negative, it's going to open down like a frown. So that's something you can get from the a, and that's consistent with both forms. The x-intercepts, I just put this on here. This is where the graph will cross the x-axis. If it's in standard form, to find the x-intercepts, all you use is a quadratic equation. Negative b plus or minus square root b squared minus 4ac, all divided by 2a. And that'll give you either none, 1, or 2 x-intercepts for a graph of a quadratic. Moving over to the vertex form, the reason it's called the vertex form is it gives you the vertex right away. If you see you have a times x minus h quantity squared plus k. The h is the x coordinate and the k is the y coordinate. So all you have to do is look at those two numbers. Where people kind of mess up on this form is they don't realize that the h, there's a minus in front of it. So for example, if it's x minus 2, then the x-coordinate is 2. If it was like x plus 2, the coordinate is going to be negative 2. Also from the vertex form, the axis of symmetry, again, is just x equals h. Hopefully you can put together that h is the same as negative b over 2a. The y-intercept, all you do to find the y-intercept is, that's where the graph crosses the y-axis, let x equal 0 and solve for y. To find the x-intercepts, you let y equal 0 and solve for x. So those are your two forms that I hope that you have seen before and are a little bit familiar with. I wanted to do a chart so that it's all in one place for you and you can find it. Let's go on and do some examples of how to use these. First off, this is just showing you, this picture's not on your notes, but it shows you that if you have a positive x squared, it's going to open up. If you have a negative x squared, it's going to open down. When you go to write the equation of a parabola, the first thing you should do is find the vertex. Vertex, in case you don't know, that's always the first thing, no matter what problem you have with the parabola, because the vertex, it's not only just the vertex, and gives you the equations, but it tells you, is it a max, is it a min? So a lot of the application problems, you'll find the vertex. To start off with, number 1, find the vertex. In this case, it's 2, -5. That right away gives you h and k, so you can go ahead and use your vertex form. The reason they give you the second point on the parabola is to find the little a. You already have h and k out of the vertex form, but the point on the parabola, or that extra point, is used to find little a after you put in the h and k. So you're going to use this vertex form. Right away from the graph, you've got h and k. You've got 2 out of the 3 numbers you need to find the equation. So you're going to go ahead and stick in 2 for h and stick in a -5 for the k. This is when the a comes in. So you already know almost the whole function. The only thing you need is, what is a? What is the vertical stretch or shrink? So we're going to use that point 0, -3. We put a 0 in for the x and a -3 in for the y, and then we're going to solve that equation for a. If you solve that down, you're going to get 2 = 4a. Then divide both sides by 4 and you'll get 1/2 = a. Now you have all 3 numbers and you can get that equation very easily. So you're going to have y = 1/2 times the quantity x minus 2 squared minus 5, and that's going to give you the equation of your parabola. When you're using the vertex form to graph the parabola, it's very simple. Now your book talks about, and we just did, transformative graphs where you're shifting things around, and yes, shift happens, but in this case I would just find the vertex first and find a couple points that are on the parabola. I would not do the whole shifting thing. So first off, I'm going to find the vertex, and if you want to use the shifting thing, you'd say the vertex is 1 unit left and 2 units down from the origin. But since you've got, you see that a is 2/3 and you know it's not going to be a straight parabola, this is why I would find the vertex, then find a couple points that are on there. So first off, the vertex is going to be -1. I know it says x plus 1, but I tell you every time, your x's always screw stuff up, so you've got to change the sign of that. And then -2 would be your y coordinate. Axis of symmetry is x = 1. That means if you get one side of the parabola, you can reflect it across and get the other side very easily. So we're going to find another point, not just the vertex. We're going to find, I go ahead and graph that vertex right there. So I graph the vertex -1, -2. Then I pick some x values on one side of the vertex, either to the right of it or to the left of it. I'm going to pick x = 2, which is to the right of it, because if I find that point, I can reflect it across and get another point on the parabola, and I'll have that nice little U shape. So there's my axis of symmetry. That's the fold line. To find another point, you pick a value for x, like in this case 2, and we're going to put that into our equation and find what y would have to equal. So 2 goes in for x. If you solve that all down, you get 4. So the graph, the point on the parabola is 2, 4. So let's go ahead and plot that point. There he comes. And I'm going to reflect him across. That means that point is going to go over to the other side. It'd end up at -4, 4. So here he goes. He's reflecting across that line of symmetry, and that pretty much gives you enough to graph the curve. So there's the curve. Alright, graphing it if it is in standard form. Like I said, you find the vertex first. When standard form, if you look at your chart, it says you can use a formula. So that's what we're going to use. We're going to use the fact that a = 1/2, b = 1, and c = 3. So we label those and plug them into the formula. We're going to find the x coordinate of the vertex, which is -b/2a. So opposite of b in this case is -1, and a is 1/2. So you're going to have -1/2 times 1/2. 2 times 1/2 is 1. So you end up with -1/1, which is -1. At this point, you can just plug that -1 in for x and get the y coordinate, and that would be pretty easy. There's also another formula that you can use that I didn't show you on the chart, but it's that the y coordinate is c minus b squared over 4a. So I just wanted to stick that in here because sometimes it's easier just to plug those numbers in and crunch them. So -1 is your x coordinate, and then I use the a, b, and c at the top again to find the y coordinate. So c is 3 and b is 1 and a is 1/2. So I put those into the formula and crank it out. So I get 3 minus 1/2, which is 2.5 or 2.5. Notice if I would have put -1 in the quadratic, I would have had 1/2 times 1 minus 1 plus 3. So you would have got the same answer. So we'd have -1 and 2.5. Axis of symmetry is always the x coordinate of your vertex. So it's going to be x equals -1. Y-intercept, that came up right away. That's always your constant, 0, 3. And you can see if you put a 0 in for the x's, that they'll cancel out and just leave the 3 there. So let's go ahead and plot these things. So we've got the vertex, plot the axis of symmetry, and then 0, 3 is your y-intercept. So I'm going to make a chart if you want to get a couple other points on there. 0, 3 we already have. If I put a 1 in for x, I'm going to get 4.5. And if I put a 2 in for x, I'll end up with 7. So once I plot those points, what you can do is reflect them across the axis of symmetry and then connect them. So there's what the graph would look like. The only reason you do some extra points is to get your curve to look very accurate and very nice. Converting to vertex form, that's the other thing you're going to have to do. This is very simple because all you need is the vertex and the a. And in the vertex, in the standard form, what they have there, -7x squared minus 70 minus 169, they already give you the a. So little a is -7. That's going to be the same as it is in vertex form. B is -70 and c is 169. To find the x coordinate of the vertex, you use that formula. X equals the opposite of b over 2a. So the opposite of b would be positive 70. But if you notice on your notes, there's a little negative out in front. So we're going to go ahead and put a -70 on the top and -7 on the bottom. Just be aware that that little negative is there. When you do this out, you're going to end up with -5. So you have your x coordinate. Now this is the second way you can find the y coordinate of the vertex. And that is by substituting in that -5 into your quadratic and finding the y coordinate. So we'll put in -5 for the x's. When you crank that all out, you'll get a 6. So the vertex is at -5, 6. That's your h and your k if you look at your vertex form. So we're going to put in the -5 for the h. And remember, it's x minus h. And we're going to put a -7. That -7 came from our original standard form of the equation. So h is going to be -5 and k is going to be 6. So when you finish that out, you'll have your quadratic. -7 times the quantity x plus 5 squared plus 6. And that's the vertex form. Be careful with your signs on the h. Vertex form of the parabola is y equals -7 times the quantity x plus 5 squared plus 6. And that's it. So I hope you enjoyed this lesson, and I hope it was quick and easy and was reviewed. Now, on the back of your notes, you have what is a quick check. This was hopefully the note sheet that you used. This is your ticket into class. I want you to do those 3 problems, and you have examples to look at for those 3 problems. Bring that with you to class tomorrow, and then we're going to do an activity. Have a great day.